Today we are going to be comparing linear functions. So our objective, our ICANN statement, I can compare functions given in different forms. So we've already seen functions in different forms. We've graphed ordered pairs. We've looked at just the graph of the line, talked about a slope y-intercept. We've looked at the equation. Today we're going to put all of those skills all together and look at how the same equation or the same relationship between x's and y's can be written in multiple ways, and some ways are better suited for certain things than others. For example, so here's 4 different ways of representing a function. The first one I gave it to you is your graph function. So here's the graph. So again, one thing is I don't have arrows on this. This graph goes forever, left and right in all directions. And this is a picture of all of the ordered pairs that work. Now, there are 2 of them that are spelled out, this one and this one. But those aren't the only 2 ordered pairs. This one right here works, which is over 1/2, up and down 0. This one right here works, which is over 1.5, up 1/2. No, up 3/4. Okay, I'm going to put my scale. This is 1. So actually every 2 is 1. So this is -1 over here. Here's 1. Okay. But yeah, any of these points. So this line has an infinite number of points, but every single one of these points fits the relationship. Okay. So it shows me all of the possible points that will work. Okay. So, but this graph can also be written as an equation. So I can write this relationship between points. Again, this is just showing me how x and y relate to each other. If I know x, how do I get to y, or how they relate to each other? So I can show that in a graph. I can also write it in an equation. So I'm going to write this as an equation. I'm going to use mx plus b just because my b is right there. There's my y-intercept on my graph. I know my b is -1. Now I just need to find the slope, remembering that that is only 1/2. So if I go, so this would be up 1, up 2. So rise of 2. So for my slope, my rise is 2, and my run is 1. Run is 1. So my slope is 2 over 1. So y equals 2x minus 1. So there's an equation that also shows how x relates to y. So this shows how x relates to y, the relationship between the two. This shows it as well. Okay. So again, how x relates to y is 2 times x plus 1. Okay. All right, I can also show it in a table. So an x, y, or f of x, depending on we're doing function notation table. Okay, so like when I put in a 0, I get out a -1. We said when we put in a 1/2, we get out a 0. When I put in a 1, we get out a 1. Okay, when I plug in a -1, let's look. We can look at this. When I plug in a -1, I get out, it looks like a -3. But again, I could also put it into here. When I plug in a -1 here, 2 times -1 is -2, minus 1 is -3. Again, all of these are interrelated. Okay, so I can use the graph to get the table. I can use the table to get the graph. I can use the equation to get the graph, or I can use the equation to get the table, and so on. They're all kind of related to each other. Or instead of doing it in a table, I could just have a set of ordered pairs. So a set ordered pair, you can have the point 0, -1, comma, 1/2, 0, comma, 1, 1, comma, -1, -3, and so on. Close set. Okay, and so on. So it could also be listed in a set of ordered pairs instead of a table. Okay. So what we're going to be doing is we're going to be looking at functions written in different ways and talking about them and finding things about them. So here it says below are 4 linear functions. So let's get acquainted with these 4 literal functions. These 4, they tell me they're linear. The fact that they're linear tells me they have a constant rate of change. They go up by the same amount as they go over by the same amount. A constant rate of change. The rate at which it is changing is always the same, meaning always going up by 2, always going down by 5, so forth and so on. Okay, this first one, f of x equals 4x plus 3. The name of this function is f, and it's an equation. It shows me I take x times 4 and add 3 to get my output. Take my input times 4 and add 3. The name of that function is f. This function over here is over here is an ordered pair. His name is H. So over here we got Frank, over here we got Frank, over here we got Harry. And this is a list of ordered pairs. Input to output, so forth and so on. Dot, 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 meaning it can keep going. These aren't the only inputs and outputs. Okay. Here's another one. This one's given as a graph. If you notice, there's a blue G right there, which tells me this guy's name is G or George, whatever you want to call him. And we have an equation. Okay. And then this last one is J. I don't know, John. Okay, we'll call him. And again, it's given in a table. But again, look, this dot, dot, dot down at the bottom tells me these keep going. This is an exhaustive list. It's not the end of all the points. They just listed some of them. So now we want to answer some questions. We want to identify the rate of change of each function. Okay, rate of change. What is rate of change? Well, if we don't remember, we can always go back and check our notes. I believe that's back here. Ooh, determine the rate of change. Determine the rate of change. What is rate of change? Do we talk about that here? Rate of change. Rate of change right here is the ratio, that's the division, of the amount of change in the dependent, or y, variable to the amount of change in the independent variable, or AKA slope with context. So it's my change up and down, and my change left and right, or my rise over run. Okay, that'll help me. So we want rate of change. Oh, sorry, wrong notes. Okay, so we want the rate of change of each function, or basically that slope. We want to know the rate at which each of them is changing. Explain how you calculated the slope for each form. So, okay, let's do one at a time. Let's go ahead and look at the slope of f. So the slope of f is, well, mx plus b. That one's just simple. It's 4. The slope of f equals 4. Okay. Maybe we shouldn't use an equal sign. The slope of f is 4. Okay. So what about the slope of, which one do we want to do next? Over to h, just kind of do them in order. Slope of h is, that one's a little harder to read. I think I'm going to do change in y over change in x. So let's look at my y. How is it changing from here to here? From -2 to 6, up 2 to 0, up 6 more, up 8. Oh, can't see that up there. Up 8. Now let's see, does that work from 6? So my y went up by 8, so my change in y is positive 8. What about my change in x? From 0 to 2, that went up by 2. So my slope is 4 for that one as well. Okay, let's try a different point just to make sense, just to make sure. What about from 22 to 30? That goes up by 8. 6 to 8 up by 2, and the ratio of 8 to 2 is also 4. Okay, so the slope of h is also 4. Okay, so now let's find the slope of g right here. I'm going to use rise and run for the slope of g. So from here I'm at -2, so there'd be 1, up 1, 2, 3, 4, 5, 6, up 6, over 2, up 6 over 2, so the slope of g is up 6 over 2, which is 3. Okay, and last one, we need the slope of j. Okay, change, I think I'm going to do the change in y over change in x. So my y, this one goes up by 5. This one goes up by 1. So 5 over 1, which is 5. Let's double check another point. What about from here to here? 16 to 21, yep, that's up by 5. 3 to 4, up by 1. Yep, slope is 5. So there, we found the slope of each one. So j is 4, h is 4. They have the same slope. G is 3, j is 5. Explain how you calculated the slope for each form. What do? We found change in y over change in x for these two. Okay, so for h and j, we did change in y over change in x. For g, what did we use? Rise over run. And then for this one, we used y equals mx plus b. to find the slope. Okay. So depending on how it's written, we kind of did it a different way. Okay, next one. Evaluate each function value when x is equal to 0. Explain how you calculated the function value for each form. Okay, so let's go ahead and let's do f. So I want to have when x is, so my function is f of x equals 4x plus 3. But I want x to be 0. So what are we going to do? We're going to input a 0 in for x. It says to explain, so I'm going to kind of explain before I get going. So I need to find f of 0. 4 times 0 plus 3. 4 times 0 equals 3. So f of 0, the output is 3 for f. So we input a 0 in the equation for x, since it's written as an equation. Okay, so next, we want to do h. Okay, let's look at h here. We want an input of 0. Well, there it is. The output is negative 2. So h of 0 equals negative 2. What did we do? Found the ordered pair with a 0 for x. So we found the ordered pair. We found the thing in this list. Oh, sorry. We found the thing in this list that had a 0 for x. And that tells me that because, again, we want x to be 0 down here. Okay, next. Let's go ahead and let's do g. So here, g, we have the graph. So I want an input of 0. There it is. Or basically, what do I find? I find the y-intercept. So g of 0 equals, sorry, a lot of scrolling, negative 2. What did we do? Found the y-intercept. Since the y-intercept is going to be the point 0, y. So there we found the y-intercept. Okay, last one. Here, j, input of 0, output of 1. So j of 0 equals 1. What did we do? Found the x equals 0 entry in the table. Okay, so we found when basically we're looking for that guy right there. When x equals 0, what's y? So we found the x equals 0 entry in the table. All right. All right, now we're going to have 4 new ones. We're going to answer a few questions about these. One thing that's different about this one is we're going to be looking at a verbal description. We haven't talked about a verbal description yet, so we'll go ahead. Basically, it's just describing how x and y relate to each other in words. So here we have, again, 4 linear functions. Again, they tell us they're linear, which means they have a constant rate of change. Identify the function that has the greatest value when x equals 15. So I need to find when x equals 15. So I'm going to go ahead and I'm going to look at the equation one because I can just plug that one in. When x equals 15, 2 times 15 plus 4. 2 times 15 is 30 plus 4. I get 34. Okay, so far this one's looking pretty big. So that one I get 34. Okay, verbal description. As x increases by 1, h of x increases by 2. So what this information is giving me is the rate of change or the slope. And since slope is rise, which is my up and down, over my run, which is my left and right, rise is y, again, run is x. X increases by 1, so that tells me that my run is positive 1. So here my run is positive 1. My rise, my h of x increases, which goes up. So this here is telling me my run. This part here is telling me my rise. My rise is going up by 2. So I know this has a slope of 2. When x equals 4, so this is input, h of x equals 5. This is output. Input is my x, output is my y. So this is telling me I have the ordered pair 4, 5. So 4, 5 is a point on this graph, and it goes up by 2, for every 1 over. So again, I want to find what's the output when x is 15. I'm thinking to get that, I'm going to write the equation just because that I think is going to be easiest. I could count up. I could be like, okay, as x goes up by 1, so that'd be 5. Y has to go up by 2, so that'd be 7. And I could keep going until I get the ordered pair for 15. Okay, I could. That I think is going to take me a while. So instead, I'm going to use, since I know the slope and I know a point, I'm going to use point slope. Oh, I did not finish the word point. It needs a T. Sorry. Point slope form, which is y minus y1 m x minus x1. So my equation ends up being y minus my y1 is 5 for my ordered pair 5 equals 2x minus x1, which my x1 there is 4 from that. So there's my equation. I now have an equation here. So now I can multiply it out, but really my end goal is to find out what's my y when x equals 15. I'm just going to plug a y in for my 15 in for my x and work it out. Okay, so 15 minus 4 is 11. So I have 2 times 11. Sorry, I'm out of room. Y minus 5 equals 22. Let's add 5 to both sides. Y equals 27. So this would have the ordered pair 15, 27. So far has the greatest Y value. So far F's in the lead. It's got a Y value of 34. This one only has 27. So far F's the biggest. Okay, let's keep going. So now G. Okay, so if you notice, this one here is called function G. Is that G right there? Okay, function G. I need to know what's the output when x is 15, but we run into some issues. I need x to be 15, which is going to be way the heck out here. So I could move this to bigger graph paper and see what's happening, or I'm going to write the equation. Okay, again, I think in this case, that's going to be the easiest to deal with. So y equals, in this case, I'm going to use mx plus b because I know my b is right there. My y-intercept is -1. So I know my b is -1. I just need to find my slope. Rise up 1, 2, 3, 4, 5 over 1 to get to a nice point. Up 5 over 1. So my slope is 5 over 1. So my equation, y equals 5x minus 1. Okay, again, what happens when x is 15? So let's plug a 15. Y equals 5 times 15 minus 1. I don't know 5 times 15. Sorry. 5 times 15. 75. Oh, sorry, wrong one. 75 minus 1. Y equals 74. All right, so far now G is in the lead. G has a bigger output when x is 15 compared to my 34. 34 is out. Now we're at G. Okay, so then now this next one. Okay, we're looking at a table here for function J. So this guy is function J. Here we have a nice table. But again, I need to know when my input is 15, what's my output? I could continue this table on. I could. That might take me a while. I think I'm going to write an equation for this as well. So in many times, writing equation is like the easiest way to tell stuff about it. So that's why we like equations and we like to write equations. So for this guy, y equals mx plus b, my slope. Change in y. This goes up by 3. This goes up by 1. So my slope is 3x. My y-intercept. Again, the y-intercept is going to have an x coordinate of 0, which is right there. My y-intercept is 4. So y equals 3x plus 4. And again, we want to know what happens when x is 15. Y equals 3 times 15 plus 4. 3 times 15 is 45 plus 4. 49. Okay, so which one? The final question, identify the function that has the greatest value when x equals 15. So my final answer, G has the greatest value. Of 74 when x equals 15. All right, so now which function has the smallest x-intercept. Ooh, x-intercept. The x-intercept occurs when y is 0. When y is 0. Okay, so first off, now that I have all these nice equations, I have an equation for each of them. I can go ahead and let y be 0 for each of them. So meaning I need the output to be 0. I'm trying to find an input. Okay, so I can take f here. Basically, I want this output to be 0. I want this guy, this f of x, to be 0. So I'm setting each one equal to 0. So for f, 2x plus 4, where does that equal 0? 2x equals negative 4, divide by 2. X equals negative 2. So the x-intercept for this case is negative 2. So that's for f. Okay, now let's go ahead and let's do h. Again, my equation for h is y minus 5 equals 2x minus 4. Again, we want this output to be 0. 0 minus 5 equals, I'm going to distribute 2x minus 8. So negative 5. Let's add 8 to both sides. What does that give me? 3 divided by 2. X equals 3 halves, which if I'm trying to tell which is smaller, that's 1.5. Okay, so again, I'm just letting the y be 0 because I want to find the x-intercept. All right, next, so that's, oh, sorry, that's for h. That's label. So now for g. Okay, we have this nice equation, y equals 5x minus 1. Okay, let's let y be 0. Let's add 1 to both sides. 1 equals 5x divided by 5. X equals, oh, sorry, that's a 5. X equals 1/5, which 1/5 as a decimal, because so we can compare, is 0.2. Okay, so far 1/5 is the smallest, but we have one less to check, and that is J. Okay, and we have an equation for that, y equals 3x plus 4. And let this be 0. Subtract 4 from both sides. X equals negative 4/3. Hey, we're in the negatives. Which has the smallest x-intercept? Oh, well, look, this one's negative 2. That's the smallest of all of them. So F has the smallest x-intercept of negative 2. Hey, best of luck.